All right, let's see if we can throw together this last example. This is improper integral using integration by parts. And so let's see if we can be very careful. The devil is in the details here, and this is loaded with details. It's loaded with negative signs, so be very cautious here. I'm going to rewrite this as the limit as b goes to infinity of, and now this is the integral from 0 to b of x e to the negative x dx. All right? This antiderivative is parts. Anytime I have the product of two functions, at least one of which is transcendental. So we're going to do parts. We have u, du. We have v, dv. What do we have? Let dv be the most complicated piece whose antiderivative we know. The antiderivative of e to the negative x is negative e to the negative x. That's the 1 over a rule. 1 over a, where a is negative 1. And then u is everything else. Well, there's not much else left. And so the parts are all present. Now, this is the limit as b goes to infinity of all this antiderivative, is all the parts is inside this bracket. So this limits this outside last thing we're going to do here. And so we have uv, so that's negative x e to the negative x, be careful, uv, and this is evaluated from 0 to b. If you don't put this in, then you have there's a missing piece of the puzzle. I'll show you this in just a bit. Minus integral. Now I need v du. Du is x. Dx. But what is v? V is negative e to the negative x. Negative e, I can cancel that. This is also from 0 to b. Now, if you don't put these limits in, watch, if you don't put these limits in, you have negative x e to the negative x. This never gets evaluated. This needs to be evaluated also, evaluated from 0 to b. Anytime you do integration by parts with a definite integral, the uv is evaluated from lower limit to upper limit. All right, the next piece is straightforward. The antiderivative is not quite finished, but I think we can finish that. And I'm going to simplify this sort of on the fly, if you don't mind. I'm going to write this as negative x over e to the x. And that's going to be evaluated from 0 to b. Get rid of the negative sign while I'm at it here. And then plus the antiderivative of e to the negative x is negative e to the negative x. It hasn't changed in the last few minutes. So this is negative because of the antiderivative, e to the negative x, and that's evaluated from 0 to b. See how I have this evaluated from 0 to b? If they are evaluated from and to the same limits of integration, you may combine these statements. If these are not the same limits of integration, then these may not be combined. So I'm going to combine these into one. I think it's going to be a little bit clearer because there's going to be a lot going on here. I want to combine these into one statement. This is now negative x over e to the x. This is minus 1 over e to the x. And this is evaluated from 0 to b. So I think that makes it a little bit more concise to have one expression evaluated from 0 to b rather than have to fiddle through all these different pieces. So what's left now, I still have the limit. So what have we done? Change to a limit statement, do the antiderivative, simplify the antiderivative, evaluate at the top minus evaluate at the bottom. So we're going to evaluate at the top expression minus evaluate at the bottom expression. At the top, it's negative b over e to the b. Minus, I should be careful here. Negative b over e to the b minus 1 over e to the b. Evaluate at the top. Minus evaluate at the bottom. That's going to be 0. Well, I'll put all the details in this time. Negative 0 over e to the 0 minus 1 over e to the 0. So what do we have out of all that? I'm going to simplify this just a little bit here before I worry about this limit. This is still negative b over e to the b minus 1 over e to the b. But what is this? 0 divided by 1 is 0, so that's 0. This is e to the 0 is 1, so this is 1 minus negative. This is plus 1. All right? Minus negative 1 over e to the 0, that's 1. Now, the last piece is evaluate this limit. But look, if you substitute and simplify, this piece is no problem. In fact, I'm going to do this piece already. As b goes to infinity, don't we have e raised to the infinity? And we know 1 over infinity in our infinity arithmetic. As b goes to infinity, forget this part, that's e to the infinity. We know 1 over infinity is 0. So this piece in the limit goes to 0. So what we're left with is the limit as b goes to infinity. At long last, negative b over e to the b plus 1. The limit of a constant is the constant. That part's not a problem. You substitute and simplify. But what we have, do you see it, is infinity divided by infinity. Direct substitution gives infinity divided by infinity. And we know what to do with infinity divided by infinity. That's why we talked about L'Hopital's rule immediately in front of these improper integrals. And so this is infinity over infinity. So this is equal by L'Hopital's rule to the limit of negative, the derivative of b with respect to b, derivative of b is 1. The derivative of e to the b is e to the b. And now it's easy. As b goes to infinity, this is e to the infinity. E raised to the infinity power is infinity. So when we actually evaluate, this is negative 1 over infinity plus 1. 1 over infinity is 0. Which is 1. So there is plenty to do. It's not very hard to see there's plenty to do. But I think if you keep your wits about you and keep the procedure in mind and do one bit at a time, it's not as brutal as it might be. And I know when I say it's not as brutal as it might be, it sounds like I'm talking about marriage or something. But no, this is not as brutal as it might be. If you keep yourself centered on what the procedure is. Change to a limit statement. Find the antiderivative using whatever procedure you need to find the antiderivative. Evaluate the upper limit of integration minus evaluate the lower limit of integration. Simplify that. And then the last little piece is evaluate this outside limit. That's why this limit is just lurking outside this computation until it has a chance to do its little bit. That little bit goes to 0 in this case. And so our final result is just 1.